we see we have items in the box. Items in the box, they are supposed to be 5. Packed boxes, there are 2, just because I pressed this one 2 times. You can see it's already on. When it reaches here, we go, this one comes on by itself automatically. And as it comes on automatically, here you can see the signal here changes. It's showing the product is loading. And once the product is loading, uh, up to 5, this is 1, this is 2, this is 3, this is 4. When it gets 5, that means loading is done. You can see there is no loading, and then the box has to proceed. When the box reaches here, this sensor senses it, and we have a new box. So now you can see we have 3 boxes. There is no loading. This motor is running the conveyor belt here, and as this one is running automatically, this one has to be off. So definitely our system is working well.
Hello, welcome everyone. This is yet another video of PLC programming. As you know, we are dealing with PLC programming series where we are running Delta PLC. One of the advantages I chose Delta PLC is because everything is still open source software. You can access it online, you simulate and you do your hardware projects as I normally do. So in today's video, we are going to work on a project of conveyor belt packing system. Whenever I want to first share with you like the art of PLCs. The art of PLCs is where a client will come to you and give you the idea he has in his mind, like I want a product that is going to do this and this for me. Or sometimes you find a client is having his system that is running with a manual mode. Everything is run manually and they want to upgrade and go automatically. So like in this kind of a system, we have a feeder here, this side of a feeder, and then we have this side of a delivery. Assume it was operating manually. When this motor is fired, this motor is on.
The video that I was recording actually collapsed in terms of audio, but then I tried to do the same explanation using my HMI. If I go offline over here and then I try to elaborate, if this system was working in the manual mode, that means we have to turn on this motor manually to drive this conveyor belt, and then this box will be moving until it reaches this area, and then you stop this conveyor belt. Then you start this conveyor belt to start feeding because to be running, coming over this side. So as the feed is entering, then you have to count as well manually. Let's say we have to pack in 5 items. You have to enter in the 5 items manually, and then you stop, and then you again start over this one until the box moves out of the rail. So this is what we want manually, but automatically is the contrary. So to get to automatic, we have to program, and that's our use of these videos because we have to be learning how you can devise everything. So for programming, I already told you as a culture, we have to first have indicated our input devices. We have the start, the stop, then we have the product sensor. This one is the one that will be counting the amount of product entering into the box. And then we have the box sensor. This box sensor is used to detect the position of the box. If it has reached the other position where it's supposed to be fed, it has to stop the main conveyor. And then we have the outlet sensor. This outlet sensor will help us to count how many boxes we have filled per day or per working time schedule. So the outputs, we have only 3. One is the output to turn on the main conveyor belt motor, and then the second one is the output to turn on the sub conveyor belt. And then we have to have this one that is going to be indicating if we are loading or not. So the other ones, the counters is as per demand. The PLC programming is actually funny. We can all achieve the same thing using this different functions and techniques. So I use 2 counters, the one to count the boxes and the one to count the product entering the whatever. So I have two storage registers because one I'm using it to store the number of products because I want like each box to have 5 bars or so. And then D1 I use it to store the number of total boxes that I have, counted the entire day. So these are my comments. And then I go to the main program. So when I go to the program, uh, I have to on this one. This is to initialize. So this is to initialize the start for me, because as I told you, you can design differently, but you have to be knowing the basic. So the basic is I want to first get the condition when my motor can be on, and this is for the auxiliary, like this is for motor number to note the main conveyor, the feeding conveyor. So for the feeding conveyor to be on, I have to have the start on, the stop should be in normal close, and then I have to have counted. If I count for, let's say, from 1 up to 5, it's supposed to be on. So that means my counter is going to reach 5 and then cut off this signal. So before it reaches 5, that means I will be able to be firing. But look here very closely. This is not the output. This is the internal relay. So I will show you the reason as why I use it over here. So, and again here you can see we have latched it. So it will have to be on because the start button, it was actually supposed to be a momentary switch, but for me I use whatever, a maintain switch. So once this one is on, I want to move the number of products that I want to be putting in each box. You can put any number, 10, but for our simplicity, I use 5 because it will be easy for us to count 5 products, not to count out to 10. We shall be wasting a lot of time. And now, after that, I want a condition to turn on my main conveyor belt. My main conveyor belt is the one that is carrying the box. So how to turn it on? Definitely my start is supposed to be on. My stop is supposed to be in a normal closed condition, and then it will be off in a condition when the box has been sensed. So this sense of the box is in a normal close, but whenever the sensor gets a signal, it is going to cut off. That means our main conveyor belt is going to be off, and that's what we want. So as when it cuts off, it starts being fed. You get it? So this is our signal M1. Also, it is the internal relay. So after that, I want to turn it on, the main conveyor. So I can turn on the main conveyor when we have a signal here, because this is what we have to command it to be on. Then it can only be on when the sub conveyor is off, because we don't want them to run simultaneously. So this is what we call interlocking. This one and this one are not supposed to be running at the same time. So I have the main conveyor uh, internal relay on. Then when this one is off, my main conveyor can be moving. You get it? So as the main conveyor is moving, you don't expect, of course, anything until this box sensor senses something. And when the box sensor senses something, we have to find our sub conveyor moving on. So our sub conveyor moves on when we have this M0, the one I told you, this one is for the sub conveyor. When it is on, and now when it is on, and now the main conveyor is off, our sub conveyor starts moving. But remember, our sub conveyor is going to move with the condition of stopping. And the condition of stopping is when our count reaches the one of the number of products we want in the box. So our count is here. Whenever X2 senses, it increases the counter number. It increases the counter number. 3, 4, 5. Whenever it reaches 5, we expect that conveyor belt, the sub conveyor, to go off. And to go off, this one has to be off, the M0. And the M0, that's why we put this counter number. At first, I explained to you, and right now, I think you can get the reason as why this is there. So whenever it goes past 5, this one it goes in a normal open condition, and now it means our conveyor M0 signal internally relay is no longer energized, so it is off. And um, once it is off, definitely our main conveyor runs again. And when our main conveyor runs, we want to restart the counter, because the next coming, if we don't restart the counter, it will continue from 5 up to more numbers. So we don't want that. And then at the outlet side, we have to have a counter that is counting how many numbers of box with the falling edge signal. So we have, let's say we expect up the whole day to produce more than 1,000 boxes. We can put, I mean, below that, we can put our maximum numbers 1,000. But here we are going to be incrementing by 1. So this is our project. We can compile it, zero errors and zero everything. So we download it to the PLC, and then we run. We go offline, online, we put the communication, yes, and now we can bring in our HMI. So basically, we want to see if we have achieved our automation. So in our automation, we expect that if we start, this is the screen that the customer is having. It's a customer's screen, and he will be having it in his control room, or maybe wherever he controls his system from. So we expect if he presses start, immediately this conveyor belt is supposed to be running. The conveyor belt is supposed to be running until the box on the conveyor belt reaches this position. So when this box moves, it proceeds and reaches this position. Now this sensor will have sensed. Whenever this, because it's sensing with the falling edge signal, when it senses and then it comes back, but the product is already here. So our box is here, and you can see whenever our box reaches here, automatically this conveyor brings itself on as well. And now we use this sensor. So whenever we feed in something, this sensor will be sensing, let's say 1. You see, there is a count of 1 inside. Now there's a count of 2. Again, senses the third component, fourth component, fifth component. So you see, when it comes to 5 components, it stops itself automatically, and now this conveyor starts itself again until it reaches here. So assume this box has reached here. This sensor has constantly measure something, and this box goes away. So we have a new box. But now you can check on the results. If you check on the results, uh, we see we have items in the box. Items in the box, they are supposed to be 5. Packed boxes, there are 2, just because I pressed this one 2 times. You can see it's already on. When it reaches here, we go, this one comes on by itself automatically, and as it comes on automatically, here you can see the signal here changes. It's showing the product is loading, and once the product is loading, uh up to 5, this is 1, this is 2, this is 3, this is 4. When it gets 5, that means loading is done. You can see there is no loading, and then the box has to proceed. When the box reaches here, this sensor senses it, and we have a new box. So now you can see we have 3 boxes. There is no loading. This motor is running the conveyor belt here, and as this one is running, automatically this one has to be off. So definitely our system is working well. You can dispatch it and give it to your client. So I think we have proceeded to a new level of dealing with projects. If you have any idea and you want, or any case scenario you want us to implement, you can bring it up, or I'll be bringing more examples for us to practice. Thank you.